You know that feeling, right? You're in a game and you have to choose between these absolutely gorgeous cinematic graphics and that buttery smooth, responsive gameplay. For years, that's been the classic dilemma in PC gaming. But what if I told you a new kind of tech is changing all the rules? Today, we're diving deep into AI upscaling. We're going to demystify all those acronyms you see everywhere, DLSS, FSR, XeSS, and figure out what they actually mean for you. So here's our game plan for today. First, we're going to start with that core problem every gamer has faced. Then, we'll unveil the AI solution that feels like a bit of a magic trick. We'll peek under the hood to see how it all works, show you how you're actually in control, explore the massive impact it's having on the entire industry, and then we'll finish up with a real, honest look at why it's not quite perfect. At least, not yet. All right, let's get into it. Section 1, the gamer's dilemma. This really gets to the heart of a conflict that has been around in PC gaming for decades. This is it. This is the fundamental question every single PC gamer has to ask themselves. Do you crank up every setting to the max for those stunning, breathtaking visuals, or do you dial things back to make sure your game is super responsive and lightning fast? It's a tough call. And here's that classic trade-off in black and white. You can push for that incredible visual fidelity, that jaw-dropping, immersive world. But the price you pay is that your graphics card might start to struggle. You get stuttering, low frame rates. It just doesn't feel good. On the other hand, you can prioritize that high frame rate, which is awesome for competitive play, but it usually means you have to turn down the resolution and sacrifice all the beautiful details the developers worked so hard on. Getting both at the same time, that has always been the holy grail. So how do we break out of this cycle? Well, that brings us to Section 2, the AI magic trick. This is where things get really cool, because we're talking about a solution that is completely changing the game. At its heart, AI-assisted upscaling is just an incredibly clever workaround. See, instead of making your graphics card sweat to render every single pixel of, say, a 4K image, the game renders a much smaller, easier version, like 1080p. Then this really smart AI algorithm jumps in, takes a look at that smaller image, and intelligently predicts what the full-size version should look like. It's basically the definition of having your cake and eating it too. Okay, so you've probably heard these names floating around. There are 3 main players on the field, and each one comes from a big hardware company. You've got DLSS from NVIDIA, FSR from AMD, and XeSS from Intel. Now, they all do things a little differently behind the scenes, but they all share the exact same goal: give you way more performance without you really noticing a drop in visual quality. All right, Section 3, how the trick works. So what's actually going on inside your machine when you flick this switch in the settings? Let's pull back the curtain and see how this magic act is really performed. Let's break this down, step by step. First, your graphics card renders that low-resolution frame we talked about. Easy enough. For step 2, it also gathers something called motion vectors. That's just a fancy term for data that tells the AI which way things on the screen are moving. Then, for step 3, the AI algorithm takes that frame and the motion data and analyzes them together. With all that info, it moves to step 4. It starts to predict and intelligently fill in all those missing pixels to create the high-res image. And finally, and this is a really crucial step, it stabilizes everything by comparing the new frame to the ones that came before it. That's what stops any weird flickering or shimmering. Pretty smart, right? Moving on to Section 4, and this is maybe the best part. This super complex technology isn't just some black box you have no control over. No, you are completely in the driver's seat. You actually get to choose what you want to prioritize. When you dive into your game's settings, you'll usually find options just like these. Quality mode is for when you want the best possible visuals, and you'll get a nice but smaller speed boost. Performance mode is the exact opposite. It's all about getting the highest frame rate possible, even if the image looks a little softer. And of course, balanced sits right there in the middle, giving you a bit of both. It's like a slider that lets you decide exactly what matters most to you in that moment. Okay, Section 5, the gaming ripple effect. Now, I want to be clear, this technology isn't just some neat little feature. It's having a huge, massive impact across the entire gaming world. And the logic here is beautifully simple. By rendering fewer pixels, your GPU can process each frame way, way faster. That directly leads to higher frames per second, which means smoother motion. And because those frames are getting to your screen quicker, the time between when you click your mouse and when you see the action happen, your input latency goes down. The whole game just feels snappier and more responsive. And here's why that is such a game changer in the real world. For starters, it lets older graphics cards hang on and run new games. That's huge. Super demanding features like ray tracing,
all of a sudden they become playable for a lot more people. Gaming on a thin and light laptop goes from being okay to a genuinely great experience. And if you've spent money on a high refresh rate monitor, well, now you can actually hit the ultra-high frame rates that monitor was built for. It unlocks potential everywhere. But of course, no tech is a silver bullet. And to get the full picture, we have to talk about where AI upscaling still has some room to grow. So for our last section, let's look at the fact that it's not perfect.
So what are the catches? Well, there are a few big ones. Sometimes the AI just makes a mistake. You might see weird visual glitches like ghosting behind a fast-moving car or some smearing in complex scenes. Also, a lot of the most advanced, best-looking features are often locked to the newest, most expensive graphics cards. And maybe the biggest concern is this. Some worry that developers might start to use upscaling as a crutch, that they might release games that aren't well optimized and just expect these tools to make them playable. Which leaves us with this final, really critical question for the future of gaming. Is AI upscaling a brilliant shortcut that's pushing graphics forward for everyone, or is it a crutch that might let developers get away with poor game optimization? The honest truth is, right now, it's a little bit of both. And where that balance lands in the coming years is going to shape how games are made and played for a long time to come.